In this series of videos I'm going over how I got into programming PC systems, embedded firmware, that sort of thing, and how I initially managed to get hold of PCs back in the 1980s. And in the first video in this series I've gone over how I managed to pick up a couple of AT motherboards. Everything I got at the time was faulty. The internet didn't exist, so I was constantly having to reverse engineer things to figure out how they were supposed to work. So there wasn't a complete machine that I had that I could look at to see what cards I wanted. So that in itself was quite a complication, because back in the time when the AT systems were made, and the systems before them, the systems after then, the hardware was not anywhere near as universal as it is these days. So for example, you needed different hard drive controllers depending on which particular motherboard you had. You couldn't just mix and match, you had to make sure you got the right one. And then you had to make sure you formatted the hard disk using the controller type you were using. And this is something that was quite difficult to pick up at the time. It was just going over everything, looking into it, going through the BIOS, figuring out why things wouldn't do what I initially assumed that they should. So in the previous video I got as far as showing the motherboard up and initially running, and we ended up with these two faults on the display: floppy drive controller failure and hard drive controller failure. Now the only reason they're coming up is because in the BIOS I have told the motherboard that there should be a floppy drive and there should be a hard drive. If you disable those, you won't get those warnings, but then you won't be able to use any drives. And obviously we need some sort of interface to get data in and out of this thing. Now what I have here is the motherboard. I've got a video card plugged in so I can show you what's going on the monitor. Unfortunately I don't have a period correct video card. The card I picked up at the time, it's the one I actually initially started using on the 5150, was a Hercules mono card. So a full-size card. It was the full length of the motherboard, full height, but it only supported monochrome, and even then only a few text modes, and you couldn't really do much in the way of graphics on there. In fact, when it comes to graphics, it's kind of a complicated route that you need, even if you have a VGA card. So I'll go over that later on when we get into the programming aspects of this. But I ended up with something fairly similar to this, albeit with the video card I had initially in the 5150. This is of course the 5170 motherboard. So I decided ultimately I wanted to switch to the 5170 system. I had the case for it, so I went ahead and bolted this in. Did have different BIOS at the time. I had the 4-chip BIOS set, and only had the one version of it, but there are now multiple versions. For example, you can get a version, I said you need a video, I said you need a drive of some sort to make use of this. But some BIOS versions had built-in BASIC, so if you kind of booted the system and there was no hard drives, it would boot straight through to BASIC. So you could at least then program in BASIC, but of course you still had the issue of how did you save the programs that you created. And I did manage to get hold of a set of ROMs that had BASIC on them. I can't remember exactly what version of BASIC, but it worked fairly well, and if I remember I'll try and show you a version of that in another video. But the version of the BIOS I have in here is much closer to what I was using at the time. The main difference is this version has built-in CMOS setup and diagnostics, was the version that I had. That setup and diagnostics was actually on a floppy disk, and you had to boot to the floppy disk in order to set the machine up. So it made it kind of a catch-22 to a certain extent, that you had to set the machine up in order to set the machine up. So it was a bit of a workaround to a certain extent. And the way the easiest way of doing it is disconnect the battery, leave it for an hour, reconnect the battery, boot it up with a floppy drive attached through a suitable controller, and by default it should have enabled the generic type of floppy drive, so you could then boot to the disk and properly configure the system. Incidentally, this is just a 3 volt cell. A lot of people say these don't work on these, but they work fine. They will retain the data, and I've never had an issue with them. It's supposed to be a 6 volt cell, but I found that these cells work just fine. So where we are now is we've got the motherboard running. As you can see, we've got the video card in, albeit it's a much more modern card. Still a nicer card, but it's much more modern than the one I was using at the time. So I thought from that point it would be relatively straightforward to get the drive working. At the time I only had a floppy disk drive, and in fact it's similar to, just grab this, it was similar to this type of drive. The drive type that was fitted was a different manufacturer to this, but it was a very similar design. This is an FZ506, and this is what I'll be using in this series. Now, this one, when I got it, had a switch on the front, so you could switch between 40 and 80 tracks, and it was part of a pair of drives in a housing. And whoever had done this, or maybe the manufacturer did it, they'd modified the ribbon cable that came to the 2 drives, and they'd cut away the leads for pins 1 and 2. Pin 1's just the ground line and the plenty of ground line, so that didn't matter. But pin 2 is the mode select line that allows you to switch between double density and high density. And there was transistor and various bits and pieces on here as well as the switch. I didn't want that. I wanted that control to be from the host system, so I modified this back to the original form. But that's why it's got this in the front. Didn't have that on mine. It was just a standard 1.2 meg drive that would work either as 1.2 meg or 360k, which is what this now does. We'll come back to this in a few minutes, because I had that with the 5150, and I got it to the point where it would start reading discs, and I had a controller very similar to this. This is not the one. Unfortunately I don't have the controllers anymore, as far as I know. I can't find them. But this is the controller that was in the 5150, and it was really only for hard disks. So you might be wondering why it's got a 34 pin connector on there if it's for hard disks, and what these two are for. We'll come back to this in a few minutes, but this is generally the interface for an MFM hard disk. And when I first started doing this back in the 80s, I had assumed this hard drive controller would work in the AT motherboard, but of course it doesn't. This only really worked in the XT series machines, so it wouldn't work in this, and it took me quite a long time to figure that one out. I knew it worked because I'd had it partially running, never had a hard drive attached to it, but I had got it up to the point where I was getting an error message on the screen which indicated this was actually doing something. But in this board it doesn't do anything at all. It doesn't get rid of the hard disk interface controller failure error. Now, after reverse engineering this for a while, I realised this isn't going to work on an XT machine. It's not been addressed correctly, and there was no way this was actually going to come to life unless I made some huge changes to the BIOS. And even then, it wasn't really going to work properly because of the way this is mapped and the way the registers within this are configured. You could get it to work, but it would be non-standard, and you'd probably get a lot of problems with regards to throughput and speed and stability. Now, eventually, once I'd got this figured out that it wasn't going to work, I started looking around, talking to friends, and ultimately I got a controller that was identical to this. This is not the one. Like I said, I've unfortunately disposed of most of them, but this is identical to the controller I picked up at the time. And this is a controller that will allow you to drive up to 2 floppy drives and up to 2 hard disks. Again, they're MFM hard disks. And this didn't work. I got this off eBay recently and it didn't work. It was had some broken components on it, and also the data slicer on here didn't work either. And I think that's the fault I had on the original board that I had back in the 80s. So I put a new device in, replaced all the broken components, and I've run a basic test on this. I haven't fully run it up, so I don't know if it will properly control the hard disk, but that's what we're going to find out in this video. This LED is just the hard disk activity light. That's where the LED on the front of the machine normally connects to. And the connectors, the right hand one is the floppy drive connector. The next one is the main control connector for the hard disk or hard disks, and the 2 smaller connectors on the left are the data connector lines, which we'll again have a look at in a few minutes. So the first thing I'm going to do is plug this in, and we'll connect a floppy drive and see if we can get the floppy drive itself to work, and then we can have a look at the setup utility, the various ways we can access that, and then hopefully we can move on and see if we can get a hard disk to work. I've fitted the controller card to the motherboard. I've connected the 5¼ inch drive I showed through a floppy drive ribbon cable, connected up the power, and I removed the CMOS backup battery for a while, reconnected it, and so this is the mode that the unit will normally boot up into when you first start trying to configure it. Now, as I said, the BIOS in this machine has got a configuration utility built into it, which is what we'll use most of the time. But I thought I'd start by showing how the configuration was done when I first got the machine, because I didn't have a BIOS with a built-in CMOS setup, so you had to use a configuration disk. This is just the copy I made of it. I do still have the original, but it doesn't work too well, but I did manage to get a copy of it, and this is the one I had. In fact, this is a later version. The one I had was version 1, which again I do have the original disk and a copy. Very similar, just slightly different the way it was laid out. So we'll put that into the drive, and in theory when we boot this up now, it should try and boot from this floppy drive. So let's try that and see if it actually works. So this is of course set up as drive A. It's going through the memory self-test. Let's move the camera up so you can see it a bit more clearly. I can hear the disk being read, so it's doing something. Okay, so it's come up with the configuration utility, and you can see that what we've got on here is the very simple, but it is quite a useful configuration utility. So it will let you do diagnostics as well as configuration. So if you're going to attach a hard disk, for example, you do it through here. If you're going to attach a second floppy disk, you do it through here. If you're trying to do general diagnostics, you could do that as well. But there was nothing in the BIOS, there was no BIOS configuration. This is the only solution that you had to make any configuration changes. So it's going through and testing the system, looking for the various hardware that's plugged in. There's not a lot attached to this at the moment, of course. Okay, so it's come up, it's saying what's attached. I'll move the camera a bit higher. So as you can see, it's given us a list of what's in here, and it's actually wrong. It's saying it's got 2 diskette drives, but that's because of the way I've got the cable plugged in, so it thinks there are two drives attached. So what I'm going to do now is attach the second. I've got a 3.5 inch drive, so you might be surprised to know that these systems will support 3.5 inch floppy drives. And to make life easier for us, I'm going to attach the second drive, reconfigure the system. If I will do, I'll attach the drive and then I'll reboot and we'll go into the CMOS setup that's built into the BIOS ROMs. Just bear in mind you can do all that we're going to be doing here using this configuration disk. Just easier to show you using the BIOS configuration. I've connected a 3.5-inch drive to the second connector on the floppy drive cable, so we'll boot this up, and this time I'm going to go into the BIOS CMOS configuration that's built into our BIOS chips. But as I said, you could do exactly the same thing using the configuration disk that I just showed. So we'll go into the setup. I want to run the CMOS setup rather than do diagnostics, and it's actually already detected the drive, so surprisingly smart for its time. Haven't had to configure this, and we'll give it a try and see if it actually works. So it's not going to boot, of course, because we don't have an operating system. But the floppy disk I have in drive A is actually a boot disk for DOS 3.3. So I'm going to put that into the drive, close the drive door and hit a key. And it should boot into DOS. So back in the 1980s, this is what I was doing, trying to get it to boot up. It took me quite a long time to get this far because I had faults on the boards. And so we now have DOS up and running. I'm going to put a floppy disk into drive B and we'll see if we can access that one. And we can. So in other words, our interface now for our floppy disks are working. Now of course we don't have the C drive, so if I try accessing the C drive, we do of course get an invalid drive specification, but I can access the two floppy disks. Now this is actually how I used the system for quite a long time. I didn't have a hard disk. It was probably 6 months, 8 months from this point of getting it this far before I got a hard disk. So I was using this system like this, and what I would do for example, to experiment is I'd use a program called debug, and we'll have a look at that later when we get the 4x6 on the bench, but quite a useful utility. But I used it quite extensively for several months to program, and I used the Edlin, I was going to say it's an editor, but it's a very simple text, I suppose it is a text editor, but it's very limited, very unforgiving to use, and but that's all I had at the time. The systems didn't come with Microsoft Word or the things you'd expect these days. But again, using that means you get a lot of hands-on feel for the machine, and especially with debug you can do pretty much what you like. It's not like with modern Windows machines that won't let you access your own machine. With a machine like this, you can do pretty much anything you want with it and access any part of it you want, which is why I find them so interesting. So what we'll do now is we'll move on and look at a hard disk and how we go about attaching that. We already have the controller, of course, and I picked up a hard disk off eBay recently. Again, unfortunately I can't find the original one I used. Started off with a 10 meg hard disk, moved up to 20 meg, which was at the time huge, and the one I've got is 30 meg, but it looks almost identical to the hard disk I had at the time. The connections are the same, the sound it makes is the same, so I'll get that on the bench and we'll have a quick look at it. So this is the hard disk, and as you can see they were real beasts back in the day. Very nice in terms of their construction, very solidly made, weigh a ton, and do seem to be quite reliable considering this must be now probably 40 years old, and I'm pretty sure it still works. I have tried connecting it and spinning it up, but I haven't tried formatting it yet, but it's making all the right sounds. So what I'll do now is get this connected. Now when you connect these, there are actually two cables. We have the main interface control cable, which is this 34 cable. Looks like a floppy cable, but it's not. It's meant for connecting these MFM hard disks. And then we have the data cable, which is, as it probably sounds, it's the cable all the data goes down. So I'll get this connected to our controller card, and we'll see if we can access this drive and actually get it formatted. So I've got the hard drive connected to the controller card, got the two cables connected. I've also got some power connected to it. So the next thing we'll do is boot up, get into the BIOS configuration, and try and set this up and see if we can then access it. And again, you can do all this through the floppy drive configuration utility, but again, I'll do it through the built-in BIOS. It's just more convenient. But back in the day, I would have only had access to it through the floppy disk. So I'll take the two disks out of the drive. We'll boot this up. Go into the BIOS setup. You can hear the hard disk spinning up. Go into the CMOS setup. And what we have to do is select an appropriate type of hard disk. Now I happen to know that the geometry of this disk match the IBM Type 20 disk. So if we scroll down to Type 20, you've got this number here, and these are predefined types. The 20 meg disk I mentioned wasn't included in this list, so I actually ended up modifying my BIOS so it suited the drive I had at the time, and I did that by using debug to go through disk access. So I through a very simple software program, I generated an interrupt to try and access the hard disk, and then I followed that through using debug to find out where it was reading this data from. But this, in this case, we can just select an inbuilt type. So this is Type 20. So we've got 733 cylinders, 5 heads. We've got write pre-compensation 300 up and landing zone of 732. 17 sectors, and that gives us a 30 megabyte hard disk. So when we try to save this, it's not going to boot up because there's no operating system on here, but what I want to do is do a low-level format. Now the low-level formatting on these disks is specific to the type of controller that you're using, not the individual card, but the type of controller. So if we swap this controller for another one the same, the formatting should be okay. But I believe this was formatted with a different type of controller, and so the formatting will probably not match, and I don't want to spend time going through trying to install software just to find out that there's an issue with the hard disk later on. So what I'm going to do is try and save this, and then I want to go immediately into the diagnostics, which should allow us to do a low-level format of this disk. So we're going to diagnostics if we can, and once again you could do this through the floppy disk diagnostics, but we'll do it using the BIOS ROM. Now if it hasn't detected the hard disk, you wouldn't get this option, so the fact it's gone into this means it is kind of halfway there to working, because if it can't detect the hard disk, can't detect a floppy disk, you won't be able to access these two left-hand options. So there are a couple of things here. We can either test the media to see if there are any bad sectors, or we can go through performance tests, this sort of thing. But what I want to do here is just format it. We can tell it during the format to mark any sectors or tracks that are bad. And what it does there is it maintains a table within the hard disk electronics and it prevents bad tracks from being used by the system. It does of course reduce the size of the disk, but there's no point leaving them accessible because you just end up losing data. So we'll go into hard disk format. We've got type 20 selected. You can see it over here. At this point, if you want, you could change the type, and then we'll go through and set what we want the drive to be. So in this case I want it to be drive C. You can change the letter. Drive type 20. So the interleave is, you can speed up performance sometimes depending on the speed of the system and the speed of the drive, by having it skip sectors while it's reading, so it's ready for the next sector as soon as that sector comes to the read-write head. And it can speed things up. I'm going to leave it at 3 because that's what I've found in the past seems to work best on this particular machine with this type of drive, but you can analyse that within the diagnostics to find something that maybe would work better and give you more performance, but I'll leave it at 3 for now. Mark bad tracks. Yes, I wanted to do that, so it will analyse the tracks to see if they are usable. It does slow down the formatting, but it's well worth doing it on an old drive like this. Start cylinder number, and again you've got to tell it what to do with those bad tracks. Start cylinder number 0, end cylinder 732, so it's going to format the entire drive. Start head number 0, end head number 4, 5 heads of course, and then we'll proceed. It's going to tell us we're about to destroy everything on the disk, but we already know that, so we'll tell it to get on with it. And it's now going to go through. Shouldn't take too long. Hopefully you can see the number on the right here. It's already on cylinder 16, and we do of course have 732 to go to. So I'll leave that going for a while, and I'll get back to you once it's finished. Okay, so it's just about finished formatting, and that's now complete. What we're going to do now is get it to check the media. That is, we're going to make sure there are no bad tracks on it. So it's found one. We will find some as we go through this. It's inevitable on a drive of this age that it will have some bad tracks, but I'll leave this running. This will take a little bit longer than the formatting, but it is well worth doing this so you don't end up losing data when you try and use the machine later on. So again, I'll come back once it's finished doing this. It'll take about 15 minutes I should think, but for you it will just be a few seconds. Okay, so that's finished. As you can see, it goes through, it checks all the individual tracks, and then it goes back for any it's marked as bad, rechecks them to make sure that it wasn't a mistake, and then it writes the bad track list to the drive. So that's finished. We've only got 13 bad tracks. That's actually quite a good disk. Disks of this age normally have anything up to 100, 150 bad tracks, so it's actually quite a good disk. So this entire process I've shown so far in this video has taken about 45 minutes to get to this point. Back when I originally did it, it took about 2 months because I had to figure out how to get all this to work, repair the boards, and then go through this process, figure out how to connect the hard disk, and then get hold of a diagnostic disk. So at this point, originally, I didn't have a copy of DOS, but a colleague I worked with gave me a copy of DOS 3.2. I managed to get hold of a disk with the diagnostics on it. I think I called somebody in a company in Cambridge, and they made this one up for me for free. I went and picked it up, and it worked. It was a bootable disk, but I didn't have DOS. But the way I tested my hard disk after completing the diagnostics and the low-level format is I tried booting to the diagnostic disk, and then as I say, a friend gave me a copy of DOS 3.2, which I still have. I won't be using these disks in this video. I have copies of them. These are actually still readable. I've had these for over 40 years. or about 40 years. So yeah, quite impressive that they are still viable, but as I say, I won't be using these, don't really want to risk them. So the next step, now that we've completed the low-level format of the disk and the checking of the media for any bad tracks, is we now want to try and install an operating system. Before we do that, it's probably worth mentioning you can use these old motherboards with an IDE hard disk, but it's not that straightforward because of the way that the various registers within the IDE interface are accessed and the timing requirements for doing that. You might find that if you use something like one of these, a simple in-out card that would work fine in a Pentium machine maybe. It's a nicer card, but it's fairly flexible. So this particular one has a floppy drive interface, IDE, 2 serial ports, a game port and a parallel port, and it'll work fine for everything apart from the IDE. Now you might even find that the IDE will appear to work, and you could even go through installing DOS and it will appear to run during the installation. But when you try to reboot to the hard disk, it will just crash the machine, and if you do a check disk after booting to floppy, you'll find that you've got a lot of cross-linked allocation units and truncated files, and that's just because it's not writing the disks properly, the files properly to disk. So if you want to get around that, there are several options. I'll come back to that in a later video, but for now we'll stick to the type of hardware I was using back when I first did this. So we've got as far as formatting the hard disk. The next thing I want to do is try to install the operating system. So I've got my copy of DOS. This is DOS 3.3. 3.2 is the one I originally used. If you install a version prior to version 3, so if you try version 2, bear in mind there's some significant differences with it, and I'll come back to those when we start talking about programming. So as you can see, we've got rid of the error message, so we're no longer getting a hard disk interface error, but it's telling us we need a boot disk. So I'll put this in. This should be bootable, so I'll put it into drive A, and we should be able to now boot to the DOS floppy disk. Now if at this point you find that you can now not boot to floppy but you could before, most likely you've got the hard disk jumpers set wrong on the interface card, or the interface card is just not working properly. So we'll enter new time and date, and as you can see we have successfully booted to the DOS floppy disk. Now in these older versions of DOS you didn't have an installer. Oh, you kind of did, but it was a bit of a manual installation process using an installation program. And the later versions, you of course had the installation program that held your hand all the way through the process. But in these earlier ones, you used a program on the floppy disk. So I'll just take us through the disk contents. There should be something on here called select. And it's about the sixth one down, select.com, and that's used to install DOS from the floppy onto the hard disk. So the way you do this is you run select, you then tell it where you want to install the version of DOS you're installing. Now before we can do this, we need to prepare the hard disk. At the moment there's a hard disk that's been formatted. There is no partition on the hard disk. So before we mess with that, we want to run fdisk, fix disk. And this should allow us, if the disk and the interface, if disk drive interface are working, we should be able to create a valid partition that DOS can be installed onto. So yes, we want to create DOS partition, we want a primary partition, and we want to make that partition active. That means that's the one it will boot from. Okay, so we've now done that. We can go back, reboot to our floppy disk, and we should now have a partition we can boot to, but it's not formatted. Okay, so we've booted to DOS, and in later versions of DOS, of course, you'll just go through the installer and follow the instructions. In these older versions, there is no real installer as such. There are two programs. One's called Select, and that's what you use for first-time installation on a completely blank hard disk. And if you're reinstalling or upgrading DOS, you use a program called Replace. Both of those should be on our boot disk. We'll just check. So yes, we've got Select and we've got Replace. So we're going to use Select. We have the partition prepared, and we should now be able to install DOS onto it. So we tell it where we want to install. In this case, we're going to install it to C, and we'll create a directory called DOS. We then tell it what country code we want to use. On later versions of the DOS installer, you have a drop-down list and you'll select your country by name from the list. These older ones, you just use your country dialing code. It's got to be one that's included in the code, of course. And then you use a 2-digit code to tell it which keyboard layout you want to use. And then it should, in theory, start to install. Telling us we're going to lose everything on the drive, but that's to be expected, and there's nothing on this one anyway. Now it might come up with some errors. These are actually the old, well, I wasn't going to use them. I decided to install from the original discs, have made copies of them first, but as part of this process, as I said earlier, DOS will want to format the partition so it matches the layout it wants, so it's got the right file allocation table format, that sort of thing. So we'll format the disk. This is a high level format, it's not the low level format that we did earlier, so it won't take anything like as long. And again, if it finds any errors, it will mark them as bad and not use them. So this will take about 3 or 4 minutes. I'll get back to you once it's finished. Okay, so it's finished formatting. It doesn't take anything like as long as the low-level format, and it's now going to start copying the DOS files across to the hard disk. I get some errors here. There might be some errors on these old disks, but decided to use these rather than the new ones, just so you could see exactly what I was doing back in the 1980s. So it reads a number of files into RAM, and then it copies them to the hard disk as a group, reads some more files, copies the next ones. Okay, so it's copied all the files from that disk, and the installer doesn't bother with the rest of the files on the other disks. You have to do that manually yourself. So we'll do that next. I'm going to swap the disk and put the second disk in. So there are 3 disks. One's the startup disk, one's the operating system, and then there's another one called supplemental programs. So I'm only going to do the first 2 for the moment. You can read it. Okay, so I'm going to copy all these files across to the hard disk into the DOS folder that we created. So we use wildcards here, so we don't have to copy them all by name. And we want to copy them across to DOS. And again, if we get any errors here. Okay, that's all the files copied across. I've checked to make sure that they all copied across successfully. Actually ended up installing DOS 3.3. It decided it was probably going to be easy to explain some of the features, and the main difference between 3.2 and 3.3 is there are some utility programs in DOS 3.3 that we can use that might make it a bit easier to explain how I went about installing some of the other programs I used. But now they're copied across, we should in theory be able to boot to the C drive. So we'll try restarting the machine. So fingers crossed that this comes back to life. If it doesn't, you can normally go through the process again. Just take the floppy disk out of the drive. I was trying to boot to floppy there, I didn't take the disk out in time. So fingers crossed it will boot to the C drive, which it does. So that's good. So we've installed DOS. If at this point it doesn't boot up, then boot back to the A drive and then have a look at the C drive and make sure all the files are intact and they're copied across the way they should. I'll go over the sort of basic system files in the next video, but we'll just do a quick check to make sure that we don't have any issues here. No, it's looking fine. Okay, good. So the process I've just shown, the first time I did it, took me several months, and I had to do a lot of kind of scrounging, getting the bits of software I needed and figuring out how all this all fitted together. These days you just Google it, takes a few minutes, and but as you can see it's actually quite straightforward once you have all the bits and pieces you need and once everything works. The hard drive I originally got didn't work. Well, actually it did, but it had got some physical damage. The power connector had been snapped off. It's quite a flimsy arrangement in the corner of the drive, and somebody had managed to snap it off, and lucky for me they did, because I ended up with a very nice 10 megabyte drive. So in the next video we'll look at installing some of the software tools I used back when I started programming PCs, and probably seem familiar even if you use modern IDEs for programming PICs or something like that. You'll see a lot of similarity. There's a lot is just carryover in the way that things were done back in the 70s and 80s. It's just on far newer machines you get a nicer interface, but the general process was the same. But I still think it's worth going through and doing the same thing on a machine like this, because you can learn so much more being able to get into the inner workings of the machine. And in modern PCs, the manufacturers, and in particular the developers of the operating systems, have completely obfuscated the hardware and the software and the system, and it's kind of turned it into just a white goods box that you can't really access the inner workings of. But on an old system like this, not only could you get into the inner workings, but you quite often had to, just to get them to work. And that's where the fun was for me, and it was fascinating learning to program on these old machines. So we'll start looking at that in the next video in this series.